Indeed. So we wrote a few of them up the other day, but we did not in any way get them all. Let's talk about them. They're a good time. So, listen, here's one of them, friends. The limit as x approaches some value a. It makes no difference what a is. It makes no difference. Of f of x plus the limit as x approaches a of g of x is equal to the limit, of course, as x approaches a of the sum. Now, that's all great and good, Mr. Grimm. The way we like to say this is this. The limit of the sum is the sum of the limits. Okay? In other words, if you have this, you could just do each piece individually instead. Frequently, that is how we will use it. For instance, on this problem right here. Are you ready for it? This is exciting. The limit as x approaches 2 of x squared plus x plus 1, or something ridiculous like this. Mr. Groom, are you saying that I could just take the limit of x squared plus the limit of x plus the limit of 1? Oops. Indeed, that is what I'm saying. Why do I need to do that? It will become very much apparent later on why that is a hugely important law. Right now you're like, oh, okay, it doesn't seem that hard. It's not. Okay? But it's very important. Just like how when you times it by 0, it equals 0, and you're like, okay, that wasn't very hard. Although you were excited in 3rd grade when Mr. So-and-so told you, and you're like, I learned my 0 multiplication tables today. And you went home and you told your brother, hey, what's 1,000,000 times 0? And he went, I don't know. And you went, it's 0. And you thought you were so funny. Because I did that. Hey, but no, anyway, but it is kind of a big deal. We use that all the time, right? We factor something that equals 0, right? We say this equals 0 because, why? Because if it's this times 0 is 0, yeah? Anything times 0 is 0. So it's one of those that's kind of easy, but it's kind of cool too. It works. Notice that, oh, look, Mr. Groom, plus or minus? Yeah, because what is subtraction? It's just adding a negative, dude. It's fine. Okay? Now, that is a huge one. I cannot stress to you how important that one is. Okay? Wow, it's hard. Now, what about this one? The limit as x approaches some value of a constant. Well, I think we mentioned this the other day. What is the limit as you approach anything of a constant? How fast is the constant changing? What is the constant approaching? It's a constant, Mr. Grimm. I know. It's true. It's true. Did it work? Did you get her done? That was quick. No, I know. It's not very hard. I'm glad. No, it's good. The limit as x approaches a of x. What would that be? Come on, what would it be? A. Yeah, it would. Yeah, it would. That's right. But then that begs the question. Well, this is weird. This is odd. And in fact, we can actually take this a step further in a moment. But for right now, let's look at this. What can I do with this? What about this C? I feel like we should be able to do something with him. Well, let's think about this for a minute. Here is the graph x. Yes, y equals x. Looks like this feller. C times x. Let's say it was 2x or something. You with me on this? Let's just say it was 2x. Are you good with this? Oh, shut up, you stupid computer. So if it was y equals 2x, of course, that would look like this one, yes? A little steeper, eh? Right? Right? Yes, Mr. Groom. And so, they go through the origin, of course. So here's x equals a, yes? On this line, this would be the point a, comma, a, yes? That is, as you approach a on the x-axis, the y's also approach a, yes? Big surprise, because it's y equals x. What would it be on this line up here? This line that's, 2x. What would it be approaching? What would it be approaching? 2a. I know, right? I know, right? But wait a minute. I feel like it's the constant, you see, times the limit of x, yes? Which means that this is the limit law. Okay? That means I can rewrite this guy right here by pulling the constant outside and finding this piece here first and then timesing it by c. So that would just be c times a. But Mr. Graham, does it have to be x? No, in fact, if you had this. Yes? Then it would be equal to c times the limit, and I don't know what the limit is, so I'm not going to tell you. I'm just going to leave it like this. Doesn't matter what the function is, you can pull the c out and take the limit of the function without the constant in there. Why? Because sometimes it's easier? Yes. But here's the thing, friends. When we get to derivatives and integrals later on, they are limits. And we can do this later on. We can pull these constants out and make our lives 1,000,000 times easier. So we won't do it a whole lot when we're actually finding limits. We'll do it a little bit, but not a ton. But when we'll really use it is when we get into derivatives and integrals. We'll use that particular one a lot. We'll just pull the constant out front. Just rewrite it. It's going to be fun. It will. Good times will be had by almost everybody. Right? Good times will be had by most. Right? Did I say it right that time, Donovan? Did I get it right that time?
I think so.
Thanks, Donovan.
Yeah.
You're great, Donovan.
No.
He's already down.
I forgot close to.
What do I say every time? Don't forget the freaking C. That's what I say. Anyway.
Pretty sure it's exactly the same.
And if anybody could tell me, it would be Donovan who would quote me. I wish you could quote me the day of the pinto beans originally. I wish I could find that video. Anyway, so right here. So, yeah, so what do you think here? The product. What do you think? The limit of the product is the... Well, this looks just like we had a plus sign a minute ago, kind of, right? So if you had to guess, what would you say? The limit of the product is the product of the limits. That's right. Nice. Nice. Sure. I need a limit. I need a function. I picked a function. Look at my function. My function is 3x minus 1. I need another function. X squared minus 7. I don't know. I need a number. 10. Interesting. What is the limit of 3x cubed minus x squared minus 21x plus 7? What is the limit of that? Mr. Grimm, how did you do that? I foiled these guys out. You with me on this? You see what I'm saying? I just distributed this times this. Huh? What is the limit as x approaches 10? Well, I don't know, Mr. Grimm. I don't know. But I do know that I can take these ones individually, you see. Is there anything that x cannot be here? 3x minus 1? I don't feel like there is. I feel like anything would work in there. So this line feels like it's just going to be straight forever. And I feel like if I choose any value, I could just actually slap it in there. And so we're going to get actually 29 out of this fella, yes? Right? Because 3 times 10 plus minus 1 is 31. Is 29 here. And this one's 93. And what is 29 times 93, someone?
What do you say, so?
Oh, that's handy. I wonder what would happen if you put 10 into this fellow. Well, you would get 3,000 minus 100 minus 210 plus 7. OMG, gosh, this is right there going to give me something like 2690 plus 7. 26, 97. And it really should work out both ways. Now, we're not going to do that one a lot like that. We're going to look at it in a different fashion. But the idea is, if you have a product of functions, you can find their limits separately like this. Sometimes that will save you some time and money and effort. A little less farting around that way. Yeah. We're not going to do that a lot, okay? Like, you remember back in, like, I don't know, for you people, like 6th grade, when you learned algebra, they're like, okay, today we're going to apply the distribution property. And you're like, cool. And then, Lily, here's the thing. Lily, the candy bars are 97 cents a piece, okay? And can you use distribution to tell me how much six of them would cost? And you went, no. Lily, you're silly. Because it's obviously $1 minus 4 cents, yes? And then you're like, this times this, and you're like, okay, I have not been around much, Mrs. So-and-so, but I don't feel like we do this at the store very often, right? Right? That's a weird usage, if you will, of the distributive property. Yeah, well, theoretically it works. I don't think I ever have used that really in the real world, except I have once or twice. Like if I'm buying some tacos and they're like 99 cents or something, and then I'm like, I got 8 of them. It's going to be a little less than 8. It's going to be $7.92. All right, but it's just I'm subtracting 1 penny 8 times or whatever. So no, we are not going to try to simplify our lives a little bit in that regard using this rule. We'll use them when it comes to some actual calculus stuff. So the fact that I showed this up here, that's nice that it works that way, Mr. Groom. When are you going to apply? I'll show you in a few minutes. It's good. Now, let's see what else. Oh, I feel like if we had this fellow, you knew it was coming. It would be equal to what, do you suppose? The limit of the quotient is equal to the quotient of the limits, Mr. Groom. You're not wrong. Well, kind of you're wrong, though. Provided that g of x, oh wait, not g of x, because g of x might not exist. That the limit as x approaches a of g of x is not a goose egg. We must not have a 0 downstairs. But Mr. Groom, my function doesn't exist at a. Well, that's cool. There's a hole there. Again, that's cool. Good for you. But Mr. Groom, listen. All I'm interested in is what is the limit as you approach that value. Did you guys trade shoes?
Yeah. My shoes.
Do they fit you?
No.
Okay.
My Sperry's.
What?
My Sperry's.
I know they're nice, and then, yeah. I just was saying bare feet, and I looked around and I'm like, that doesn't look like it belongs. Cool. Nice. Yeah, that's good, because, yeah, if you wear the same size shoe, that would be, you can have small feet or very large feet either way, or maybe both. Nice. Now, there was a kid a few years ago that dressed up for one of the skits in his girlfriend's clothes, and his girlfriend was a very small girl, and he actually fit in them, sort of. I mean, they were small, but they were not as small as most of us would be. If we like Connor and I would just like, no, we're not even going to try that. But I mean, he got them on, and he didn't like ruin them either. You know, it's like you put them on, and I got them on once, sort of, but you'll never wear them again, kind of thing. No, it was weird. But yeah, he's a little fellow. All right, some of us big guys, no. Although, we were driving one time and the car broke down. I didn't have any bad pants to wear, and she'd bought a nasty pair of old sweats, and I managed to squish myself into them, and they were no good anymore after that. But they were like a little high water, and they were really tight. But I did not mess up my good slacks, so that was a plus. I did not want to ruin them. Oh, here's a question for you. What if you had the limit as, I don't know, x approaches a of some function to the nth power? What would happen if you did that? What do you want to say? But I feel like this is saying that the limit of a function to the nth power is probably going to be equal to Now, mind you, we're doing the limit.
The function.
Yes! The limit of the function to the nth power. That's right. That's right. Mr. Groom, give me an example. I would love to give you an example. Here's my example. Are you ready for it? This is pretty exciting. Hannah Morris, watch me pull a number x minus 2 squared. Squared. I'm going to take the limit of this guy as x approaches 9. Because why not? Because why not? This, you see, is equal to the limit as x approaches 9 of x minus 2. And whatever that number comes out to be, squared. And so the answer, of course, is 9 minus 2 is squared. Bam. Done. How's it going, man? Beautiful. Is that Mr. Ford?
Yeah.
That freaking kid. Were you having a good lab? Was it good? Was the lab good?
It wasn't long.
He just kept you late? What a freaking jerk. Good. All right, so you haven't missed a ton. All right, so then, wait a minute. I feel like we could probably do something along these lines. I know, right? What if you had this guy? Tell him hi for me. Tell him hi for me. Who is it? Is that the boy from the For Reals? And then yesterday you're making fun of people for saying that it was a thing when it wasn't really a thing, but it really is a thing. Okay. Yeah, because I always text people like that when during class and get all red when I get teased about it during class. I'm just
If you
teasing.
use emojis, it's a thing.
And I picked a nerve. Yeah, all right, here we go. So the square root is what power? So 1/2. So this is another way of saying this. Right? That's another way of saying that. Well, that's just a freaking power, isn't it? So I figure I could probably take the limit as x approaches a, f of x, and then, take that all to the 1/2 power.
Yep.
Or if you prefer, like that. Whichever makes you happiest. Huh? Yeah, whatever. Whichever. Yeah? Well, then that begs the question, Zach. Because I feel like if I took the limit as x approaches, well, anything, but let's say a, whatever, of, f of x to the, wait for it, m over n power. Ah! Look, dude, it's just a freaking power. All right? It makes no difference. So you're like, well, it's the same thing. Well, of course it's the same thing. Some books will write it like this, which makes sense to me, to be honest with you, yes? But you could also write it as the nth root, yes, of the limit as x approaches a of f of x, right? To the m power. Yes? What's up?
This is referring to problem 6, right? Instead of problem 8.
Yeah, I messed up around. Number 7 refers to 6. Yeah, I got rid of a bunch of problems off this old test and rearranged some crap. Got it? Make sense? It's not very hard, is it, Lace? It's not hard, is it, Lacey? No, thank you. Good answer. Good answer, Lacey. Good girl. Good girl. That's nice. Mr. Graham, I'm feeling triggered now. I know. I'm sorry. It's what I do. It's what I do. What I do. Now, let's try finding some limits, shall we? Okay. Using the laws. So watch this one right here. Tell me what you think. It is the limit as z approaches 9 over the square root of z. And on the bottom we got z minus 2. So if you look at this thing, the overarching principle here is, by God, we're doing division, are we not? So we know that this is equal to this. And yes, this is how we're going to do it. Slowly and surely, one step at a time as we're practicing. Yes? Now that top one could be done how? The square root of the limit as z approaches 9 of z. Right? Over, now wait a minute, I see a subtraction. So what do I see? I see the limit as z approaches 9 of z minus the limit as z approaches 9 of 2. I used them all just about, didn't I? Good for me. Now what is the limit as z approaches 9 of z? It's 9. And what is the square root of 9? 3. So my numerator is 3. And down here, the limit as z approaches 9 of z is 9. Minus the limit of 2, which is, of course, and 9 minus 2 is 7.
Whoa.
Ta-da! Now, I'm going to ask the question right now. Couldn't I just plug it in over here, Mr. Grom? After tomorrow, or Monday, or whenever I talk about it? Yes. Because on Monday, or whenever we talk about it, we will learn that this is a continuous function at x or z equals 9. At this point, you don't really know that per se. Okay? So we are going to use the laws step by freaking step, all the way through them. Okay? Now, as soon as you've identified this as hey, that's a continuous function, well, if it's continuous, then just throw the number in. Boom! But that's not been told yet, so we don't know that. So, and by the way, there will be times when they're not continuous and we can still play the games. So we're going to play the games here. W approaches 7 of the square root of w plus 2 plus 1 over. Ooh. Nope, sorry. Nice. Here we go, friends. Where do we start? So I see it's a quotient. So I'm going to bring this limit up on top. I'm going to do it nice and slow, a step at a time. Right? On this next one, I'll let you do 2 pieces at a time. Right? I mean, because it's kind of ridiculous at some point, right? So, I will have the square root of the limit as w approaches 7 of w plus the limit as w approaches 7 of 2. Yeah.
For the
Plus the limit.
bacterial problem,
Yes.
and so it was 20,000 after 2 hours. How long would it be after 5 hours? That's from the original population from 20,000, right?
Right. Right. Everyone see how I did that? Right? So I'm bringing this guy and passing it into here, yes. But once I'm in here, there's a sum, right? And I'm also passing the limit through over to here as well. We call that passing it through. It looks like I'm foiling, but I'm not. It's called passing it through. The limit is a linear operator. Huh? Yeah, it's a funny thing. If you're just looking at your calculator, it's hard to get pissed off just looking at a calculator. See, it's a dead giveaway. When you have an expression on your face, it's clear you're not running a calculator, because no one's ever gotten pissed off at a calculator. Well, okay, I've gotten pissed off, but I mean, it's pretty obvious that it's the calculator's fault. It's pretty obvious the calculator's fault. Oh, wait, stop. Look what I did. Look what I did. Look at it. Does it matter if I bring the negative out there? Or if I leave the negative on the inside and say it doesn't make any difference at all? Because it's still a constant, eh? Plus, now I'm going to do this in 2 steps on this one, okay? If you don't mind. I don't care if you do, I'm doing it anyways. Okay? Alright, so let's go nice and slow on the top, eh? So what is the limit of W as W approaches 7? It is 7 plus 2, right? So I'm going to change my pen here. Well, maybe I'm going to change my pen. There it is. So I've got a 9 going on in here, right? And then there's what is it going on? Is it a 7 or a 1? It's a 1. And then down here I've got a 7 and a -3, which is a foe. Cool. So the square root of 9 is 3, plus 1 is 4 on top. Square root of 4 is 2 here. Now Lily, I'm going to do this in a couple of pieces here, I think, okay? Lily, I see a multiplication. Do you see multiplication? I do too. So I'm going to pass that through that as well. Right? But wait, isn't that a constant right there?
Yeah.
So maybe we should bring it outside like that. But wait a minute, we're not done. Because now I see the limit of W squared. So how are we going to write that instead? Of W squared. Right? So 7 squared is 49. Times 2 is 98. Plus 2 is 100. 1/25. Bam. Or 4%. Or 4. Or 4%. Yeah. Whatever turns your crank, so to speak. I want it done in that sort of method. Okay, there will be no calculators used for this piece at all, except maybe if you don't know 17 squared or some such like that. There will be no graphing for this crap. You're practicing using the limit laws. Okay, that's kind of a big freaking deal. Okay, now, by the way, I never want to hear on the test again, but I don't know how to do it, Mr. Groom. Good, because that's because I gave you homework to practice on. Okay, and hopefully you figured it out by then. So one more of these, then I'll give you some time to work today. It's going to be kind of fun almost, I think. Maybe. I hope. Yeah. Okay, now I'm just going to throw this up here on the board, and I just want you to see what you think about this guy. So, the limit as, what? We may do 2 more just for fun. I don't know. 1/3. 1/3. Ooh, that's gross. Hey. Huh? So, what do we do? What do we do? Do it. What do we do? Well, look, I've got it to the 4th power, eh? And what did we say we could do? We could move the limit inside of it, yes? So we'll find that limit first. And whatever that limit is, what are we going to do to it? Take it to the 4th power. Oh, but wait! Look what I see. I see a constant times x squared. Oh, but it's x squared while I'm at it too, right? And then minus this constant stuff. So let me pass that through. I think I'll write it in 2 pieces. I think I'll write it in 2 pieces. Why aren't you writing this down? Why aren't you writing this down? I'm just asking. I'm just being nosy, I guess. But I'm just wondering why you're not writing this down. So that you can go home and practice it using your notes and whatnot and go, oh, that's how he did that. Okay? Yes?
Yes.
So then what can I do? I pull the 18 out, right? And again, if you do it in pieces, it's really not that bad. It is, but you're not going to do a ton of them, so it's not going to kill you. And as Mr. Smith says, there will never run out of trees in Oregon, so whatever. There you go. He's not wrong. We keep replanting them, and there you go. And we recycle and everything else. Now, listen, what about this business? What about this 2 right here? What about this x squared business? What can I do with this x squared? I can pull him where?
Yes.
Of that, right?
Yes.
So, what is the limit of x as x approaches 1/3? It's 1/3. And what are we going to do with that? We're going to square it and then times it by 18. And then we're going to say, what is minus 4 all to the 4th power. That's 1/9 times 18 is 2. Minus 4 is negative 2. To the 16th, to the 4 is 16. Ta-da! Negative times a negative times a negative times a negative is a positive. Ask Betsy. Nah, look what he did. Did you see that? But Betsy says, remember, when you type this into your calculator, Betsy knows the order of operations, even if you've forgotten them. So Betsy goes, please excuse my dear Aunt Sally. I don't see any parentheses. Check. Exponents. Q. I see an exponent. And Betsy says that. Why does Betsy say that? Because, unless otherwise noted, this really means that. So Betsy does to the 14, to the 4th is a 16. And then Betsy says, hey, let's do some timesing by -1. So how do I fix this? Well, I personally just remember that anything to the 4th power is going to be positive. That's my first order. But if you don't remember that, then do this. Do -2 in parentheses to the foe. Yeah, that's it. Okay. I don't know about you, but the whole negative, whatever. Just count negatives. If it's an even number of them, it's positive. Okay, it's very straightforward when you're timesing. Okay. So if it's to the 4th power, I just ignore the negative. Screw it. It's going to come out positive anyways, right? To me, that's the easier way. Then I don't have to worry about, does this calculator know what I mean or not? Because, by the way, some calculators, some cheapy, crappy calculators, you type in -2 to the 4th power, it gives you 16. It should not give you 16. But it does sometimes. Okay, so be aware of that. Okay? Back in my day, back in the old days, when you paid, I think I paid that thing about $60 for just a little handheld jobby, this little, the scientific job the first time, which my best friend, well, not after this day, erased the times and the multiply, the times and the division, and the plus and the minus sign, and the equal sign. She erased the numbers. She erased it off the buttons day one. Thanks a lot, you stupid. Yeah, I pretty much gave her a piece of my mind I could ill afford to lose. But, so to this day, still it's in my drawer, I painted over them with whiteout and then wrote them on there in whiteout, whatever. It's ridiculous. But that one, I'm pretty sure it was one of the ones, if you typed in -2 to the 4th power, it actually gave you 16, -16, if you put in -2 to the 4th power, it gave you 16, it should not have given you 16, okay? And so back in the day, programming them, they did not do as good a job as they do nowadays. All right? Back then, sometimes they forgot, the computer forgot that it was doing, it should be using its order of operations. Sure. Oops. Okay, well, Mr. Graham, I feel like we could do this. Right? Right? What do I need to know to solve this problem, though, Mr. Graham? Need to know what f of x is. No, I don't. Lacey, I do not need to know what f of x is. As a matter of fact, I am happily ignorant of what it is. What I need to know, you see, is what is the limit as x approaches 4, yes? And as it turns out, this book problem tells me that the limit as x approaches 4 is 3. And the limit as x approaches 4 of g of x is 1. Nice. So this is going to be 2 times 3 plus 3 times 1. 6 plus 3, which is 9 Rooney. Do I know what those functions are doing? I don't care. All I care about is what's going on near at those points, right? I want the limit at those values. Matter of fact, it'd be way easier if I didn't know what the actual function is. There's a lot too much screwing around. Notice I did not have to do anything with all I did was pull out a constant this time. I didn't have to worry about, to the nth power. I didn't have to worry about, f of x is really this plus this plus this plus this. I don't have to worry about that. All I do is pull the constant out front and just call it f of x. So much nicer that way. Okay. Now that is section 2.3. Okay. I think you have probably enough to work on now. Okay. So the rest of the period is yours to work on my stuff. Not English, not biology, or chemistry. Did I say English already? I'm going to say it again just for grins. No U.S. history, no AP waste of time, no blah, 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 fill in the blank, drama, whatever it is your thing is, none of that, just my stuff. No snappy chatting, no whatever else it is you feel like doing, just do my work. Okay, thanks. And then, unless you're the person who I would pay money to watch this, if you're like Miss Blount's class or something, you whip out and say, Miss Blount, I can't do what you want me to do because I'm actually doing my calculus right now. If you got a Snapchat video of that happening, I would actually laugh pretty hard about that. Okay? Because it never seems to work that way. It's always in math class, you clowns are doing English work, and it drives me bananas. Okay? Anyway, any questions from the homework you want to see from the other day or anything you want to see worked out? No? Yes? Lacey's got one. I knew you would. Hit me. Which one? What's the problem say? Excellent. 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 Read me the problem. What's the problem? Oh my gosh, Mr. Groom, for being so mean. I know. Yes, hit me. I'm listening. F of t is 12t minus 7.
And t equals t equals 9.
And what are we trying to find, dear? The limit or the instantaneous rate of change? The instantaneous rate of change. Now, before we go any further, if you graph this, what would it look like? A line. And what is the rate of change of a line called? The slope. Right? Now, what is the slope of this line? It's 12. Now, listen carefully. I do not care that it's that easy. In the future, yes, boom, you're done. Okay? But listen, we're going to try it in Excel just for fun, okay? But now, how would that work? So, because this same process works, right, for everything. So you can practice it. And we said it, what value, dear? 2? 2? 2? Well, you do it a couple of ways, but if it was me, I would just put a 2 here. And I would say equals, and I'd do like 2 minus, or not 2 minus, equals this guy minus, and you can do what you want, but I think I just do minus 0.01 because I'm kind of a fan of that. It's a nice small number. Yeah? There's nothing special about where I put it in E7. You see that? But it's just where I started at. Minus 0.01. Hit enter. And click on this guy and just drag him up. Right? And then click here and go equals this feller plus 0.01. Right? And then just click him and drag him down. Right? Then what is my formula? It was equals 12 times x, right? Right? Or whatever, right? Minus 7. Click on these and drag them down. Right? So remember, we're going to look at these 2 points here, right? The ones just before and right at that value. Right? So we're going to use this one and this one for our x's and these 2 for our y's. And then we're going to use these 2 for our y's and these 2 for our x's. Yes? We're going to get 2 different values. Not this time, but usually. And then we'll average them together. Yes? So I'm going to come right over here and say, all right, equals 17 minus 16.88 divided by 2 minus 1.99, like that, yes? You can do it on your you can do it on your iPhone if you like, right? But I like doing it here. I just click on what I want. This one minus this, that's my y's, divided by my x's. What?
So I was wondering, if you're only using those 3 values, why do you need all the other?
Well, I just like to show people, because I also use this to talk about limits, yes? So if I want to approach with the limit here, as x approaches 2, then I can zoom in on it and see what's happening. As these x's approach this value, right, then it's approaching some value. It's the same method, basically. It's just, you know, I can kind of kill 2 birds with 1 shotgun blast that way.
Okay.
Right, Lace? And then Lace down this one here. Do this one minus this one divided by this one minus that one. Right? Just, yeah, the ones right after. Oh my gosh, they're 12. But if they weren't 12, I'd probably average them and get a number somewhere between the two, yes? But since they're 12, I don't feel like I need to do that, right? And they're 12, so I'm like, wow, it's linear. Oh, duh, of course it's going to be 12, right? Maybe I didn't catch that at first. I don't know. It happens. Okay? Other questions? Other questions? What's the matter?
I'm just a little confused, like, you can do that on a calculator.
Of course you can.
Okay, could you maybe do an example of that on the calculator, just so that you don't have to use Excel?
Well, I want you to practice using Excel. Because we use Excel all the time in this class, the whole rest of the year, so you need to start getting comfortable with it. Now, I don't care. If you want to use the calculator, you would do something like this. 16.99. And, well, no, it wasn't 16.9. It was like 1.99. Plug that into here and get a value out. Plug 2 in, get a value out. I think they were something like, what were they? I don't remember. I don't even remember. But you get a value out. 16.98 or something. I don't know what it is. I don't know, whatever it was. And then it's just y minus y over x minus x. And then you're also going to want to put in like 2.01 and get a y value out. And then use these two and also find a slope. But you really should practice with Excel on something very easy, because we will be using it a lot this year. So get comfortable with it. It's a fun tool. Another question? All right, I'll come over and stare at you and make you feel uncomfortable. Now the rest of you, get busy on your homework, and yeah.